How do you convert units for thermodynamic properties? Imagine trying to compare the energy of two different systems, but they use different units like joules and British thermal units. How do you make sense of that? Well, converting units for thermodynamic properties is all about understanding what you're working with and applying the right conversion factors. First, you need to identify the property you're dealing with. Is it temperature, pressure, energy, or volume? Knowing whether it's an intensive property like temperature or pressure, or an extensive one like volume or internal energy, helps guide your conversions. Next, look at the current units. For example, temperature might be in degrees Celsius or Fahrenheit, pressure in pascals or pounds per square inch, energy in joules or British thermal units, and volume in cubic meters or cubic feet. Once you know what units you're starting with, find the correct conversion formulas. For temperature, converting Celsius to Kelvin involves adding to 173.15, while Celsius to Fahrenheit uses multiplying by 9/5 and adding 32. For pressure, 1 atmosphere equals 101,325 pascals, and 1 psi equals 6890 for 0.76 pascals. When it comes to energy, 1 British thermal unit equals 1055 joules, and 1 kilowatt-hour equals 3.6 million joules. If you're working with specific properties like specific enthalpy or specific volume, remember these are per unit mass. To convert, change the total units first and then divide or multiply by the mass units accordingly. Temperature conversions need special care because 0 points differ, so always add or subtract the correct offset. For energy units, multiply by the conversion factor to switch from one to another. For example, to convert from British thermal units per pound to kilojoules per kilogram, you multiply the British thermal units by 1055 to get joules, then convert pounds to kilograms by multiplying by 0.4536. This way, you get the energy per kilogram in kilojoules. When working with derived properties like entropy or heat capacity, convert each base unit separately and then combine them. Be aware that thermodynamic tables might use different temperature scales, so you may need to adjust property values accordingly. Always double-check your conversions to ensure accuracy. Converting units correctly makes your thermodynamic calculations consistent and comparable, no matter what measurement system you're using. Whether you're analyzing steam, refrigerants, or gases, mastering these conversions helps you work confidently with any property in any units.